We trust artificial intelligence with so much these days, our photos, our money, even our health. But what if I told you that a lot of the time, even the people who build these AIs have no idea how they are making decisions? It's a huge mystery called the AI black box. And today, we're going to crack it open. Okay, so to get this, you have to understand this one massive shift. With old school code, a programmer, writes every single rule. If this happens, then do that. Super predictable, right? But modern AI, it's a whole different ballgame. We don't give it the rules, we just give it tons of data and it comes up with the rules all by itself. And that's where things start to get, well, a little weird. And this right here, this is what everyone's talking about when they say the AI black box. It's the reason you can't just turn to an AI and ask, hey, why'd you do that? And get a straight answer. Let me break it down with an analogy. A tax program is what you'd call a white box. You can pop the hood and see the exact line of code where it multiplies your income by the tax rate. It's all there, logical, totally traceable. But a deep neural network, the kind that powers all this advanced AI, that's a black box. Data goes in and answer comes out, but what happens in the middle is a complete mystery. So, how does this actually work? Well, imagine you're trying to teach an AI to recognize a dog. You don't program it to look for floppy ears or a wet nose. Nope. You just show it thousands and thousands of pictures of dogs. The AI then looks at every single pixel, finds its own patterns, and eventually it just learns to make the call dog or not dog. It quite literally teaches itself. All this magic and all this mystery happens inside something called hidden layers. This is the true heart of the black box. It's just this massive, unbelievably complex web of mathematical connections. And inside these layers, the AI's thoughts aren't in English. They aren't even concepts. They're just numbers, like 7324. These numbers represent patterns so abstract that they have no human equivalent. So the AI knows it's a dog for sure, but it has no way of explaining why in a language we can understand. Okay, so you might be thinking, hey, if the AI is getting the right answer, who cares how it does it? Well, it turns out it matters a lot, because sometimes an AI can be right for all the wrong reasons. Let's look at a classic example. Some researchers built an AI to tell the difference between photos of wolves and huskies. I mean, that's a pretty tough task even for a person, right? And at first, it looked like a huge success. The AI was hitting 98% accuracy. It almost never got one wrong. But then the researchers decided to peek inside that black box and see how it was doing it. And what they found was completely unexpected. The AI wasn't looking at the animals at all. It had found a lazy shortcut. It noticed that in the training data, most of the pictures of wolves had snow in the background. So it just made a simple rule. If there's a bunch of white stuff in the picture, it's a wolf. The AI wasn't an animal expert. It was a glorified weather detector. And this kind of shortcut learning leads to some really serious, real world problems. Amazon had a hiring AI that started penalizing resumes with the word women's on them, simply because it learned from biased historical data. Think about it. Imagine being denied a loan or a self driving car making a life or death decision, and there is absolutely no way to know why. And all of this reveals the central dilemma that every AI developer is facing today. It's called the accuracy trade off. Here's how it breaks down. On one hand, you have simple AI models. They are super transparent, you can see exactly how they work, but they aren't very powerful. On the other hand, you have those incredibly powerful neural networks. They're crazy accurate, but they're almost completely opaque. So, right now, we're basically forced to choose between raw power and actually understanding what's going on. Just think about what that means for a second. It's as if we're working with an alien intelligence. It's brilliant, it's powerful, but it thinks in a way that's so fundamentally different from us that we literally cannot translate its language or its logic. But it's not all doom and gloom. There is a whole new field of research tackling this problem head on. It's called Explainable AI, or XAI for short, and its entire goal is to build us some flashlights so we can start peering inside that box. One popular method is called feature importance. It's basically like asking the AI to show its work. For an image, it can create a heat map that highlights the exact pixels it focused on to make a decision. So, if it's supposed to be identifying a cat, we want to see it highlighting the ears and the whiskers, not the carpet in the background. It helps us build trust that it's looking at the right things. Another really powerful tool is the counterfactual explanation. Instead of just getting a no, the AI tells you what you would need to change to get a yes. So for a loan denial, it wouldn't just say rejected. It might say, your application would have been approved if your income was $5,000 higher. See? It turns all that complex math into actionable advice for a real person. So, what does all this mean for our future? Well, it signals this really fundamental change in how we relate to technology. You see, the black box problem has really evolved. It's not just some technical puzzle for computer scientists anymore. As we weave AI into every single part of our lives, from medicine to the justice system, it becomes a much deeper question. It's a question of trust. Can we, and should we, trust a decision that we simply can't understand? This quote really just captures the shift perfectly. We are moving from programming computers to teaching them and hoping they learn the right lessons. We're not just writing instructions for computers anymore, we've become their teachers. We provide the curriculum, which is all of our data, and we just have to hope that these incredibly powerful students of ours are learning the right lessons about our world. And that leaves us with the critical question that we all have to think about moving forward. We're building these powerful minds, and we're setting them loose on our data. We're teaching them, but are we absolutely sure they're learning the right lessons?